data from the said three senses. In this video, we are tasked to answer the three following questions. First is debunk that noon is the hottest time of the day. Second one is why is the coldest air temperature is by late night or early morning. The third one is to explain radiation temperature inversion during nighttime cooling. Number 1. Debunk that noon is the hottest time of the day. So there is a misconception that noon is the hottest time of the day. So they may think that when the earth receives most of the solar radiation or the sun is directly above us, it is the most hottest time of the day. But it is somewhat surprisingly wrong. So it may sound obvious, but the hottest time of the day is much later than we all think. Although the sun is at its highest point in the sky and the earth receives most of the solar radiation coming from the sun, noon is not yet the warmest time of the day. Rather, the air during noon continues to be heated and often reaching a maximum temperature later in the afternoon. So as we can see in the picture, even though the incoming solar radiation decreases in intensity after noon, it still exceeds the outgoing heat energy for a time. So when the incoming solar radiation exceeds the outgoing heat energy from the surface of the earth, the air temperature rises. So we can now say that noon is not the warmest time of the day. So the hottest time of the day occurs in the afternoon or between 3 p.m. to 5 p.m. in the afternoon or around 3 to 5 hours after noon or after the sun receives the most amount of the solar radiation or the sun is at its highest point. So this delay is due to the Earth's surface receiving and absorbing heat at a higher rate that it is able to radiate until mid to late afternoon when the process reverses. Even though the sun's radiation starts to drop, the Earth retains much of its heat while still receiving solar radiation. So this means that the heat building at the surface is higher than that which our planet or the Earth can radiate away. So as a result, the temperature continues to rise until the solar radiation is weak enough for the Earth's ability to radiate heat back into the atmosphere. So it becomes greater than the radiation it receives. So even though the sun's radiation starts to drop, the Earth retains much of its heat while still receiving solar radiation. So this means that the heat building at the surface of the Earth is higher than which the planet can radiate away. So as a result, the temperature continues to rise until the solar radiation is weak enough for the Earth's ability to radiate heat back into the atmosphere and becomes greater than the radiation it receives. So we can now say that the hottest time of the day is in the afternoon around 3 p.m. to 5 p.m. and not in noon. So number 2. Why is the coldest air temperature is by late night or in early morning? So just like the hottest time of the day, the coldest time of the day occurs much later than we expect. So the coldest time of the day occurs late night or in the early morning. So it occurs when the sun's radiation is still weak to warm the planet, to warm the Earth's surface at a greater rate than the Earth is radiating away from the surface into the atmosphere. So as shown in the picture, the coldest time of the day or the coldest air temperature is when the outgoing energy exceeds the incoming energy. We know that nights are much cooler than days. The reason for this fact is that as the afternoon sun lowers, its energy is spread over a larger area, which reduces the heat that warms the ground. Sometime in the late afternoon or early evening, the Earth's surface and the air above begin to lose more energy than they receive. So this is due to radiational cooling. So when both the ground and the air above cool by radiating infrared energy. So the ground here is now being a much better radiator than the air is able to cool more quickly. At the same time, solar radiation decreases until completely disappearing around sunset. So the planet's surface or the Earth's surface continues to cool down as it radiates heat throughout the night. After sunrise, the ground starts to receive solar radiation, but it is still too weak to counteract the rate at which the surface continues to cool down as it radiates heat into the atmosphere. So the coldest time of the day occurs once the speed of which the Earth radiates heat is no longer stronger than the incoming solar radiation and the ground starts to warm up. So the coldest time of the day occurs in the early morning or in the late night. So number 3, explain radiation temperature inversion during nighttime cooling. So what is radiation temperature inversion? So radiation temperature inversion is the increase in air temperature with the increasing height above the surface. The ground now is a better radiator than the air so that it can now cool more quickly. So after the sunset, the Earth's surface is now slightly cooler than the air directly above it. So the surface air transfers some energy to the ground by conduction, and the ground in turn transfer or radiate energy more quickly. So as the night progresses, the ground and the air in contact continue to cool more rapidly. So during late night and early morning, the air near the surface is much cooler than the air above it. So there are conditions to have a strong inversion, to have a very low temperature. First is the air is calm, the next is the night is long, and the third one is the air is fairly dry and love-free. So in a windless night, it is essential for a strong inversion because the stiff breeze tend to mix with the colder air at the surface with the warmer air above. The next is, the longer the night, the longer the time of radiational cooling, and the better the chances that the air near the ground will be much colder than the air above it. And lastly, radiation inversion are more likely with a clear sky and dry air because the ground is able to radiate its energy to the outer space and thereby cool rapidly. So those are my answers in the following questions. Thank you for watching.